May bagal daw, architects and civil engineers of the future. Welcome to the Eiffel Tower. I mean, welcome to your online class in strength of materials or mechanics of deformable bodies. I'm your instructor, Daryl J. Amblebeen. In this video, I will discuss bending stress example 4. The wide flange section W14 times 30 with a section modulus equal to 42 cubic inches is used as a cantilever beam as shown in figure A. Find the maximum bending stress in the beam. The beam is under a concentrated load of 5,000 pounds at point A and a clockwise couple of 25,000 pound-feet at point B. Again, in this problem, we can actually sketch the shear and moment diagrams immediately. But let me first solve for the support reactions at point D, which is a fixed support. So there will be a vertical reaction at D. Let's name it dy, which acts upwards to balance the downward external force, 5,000 pounds. And the magnitude of dy is equal to 5,000 pounds, which we get by summation Fy equal to 0. So dy is 5,000 pounds acting upwards. There ought to be a horizontal reaction at the fixed support at D, but since we do not have any external horizontal forces, dx is just equal to 0. And at the fixed support, we also have a moment reaction, and let's call it md. This time, we're going to assume that it acts clockwise. We will check later on whether that assumption is correct or not. So we can get moment D by taking summation moment at point D equal to 0. So we have positive MD since the assumed direction is clockwise, and the concentrated load 5,000 pounds tends to rotate counterclockwise about point D, hence negative, and its perpendicular distance from point D is 6. And we have a clockwise couple, so we have a positive 25,000. We equate everything to 0. We can compute for MD equal to positive 5,000 pound-feet. Generating a positive value means that the assumed direction for MD is indeed correct. Now we're ready to sketch our shear diagram. At point A, we have a downward external load of 5,000 pounds. So we go down to negative 5,000. Since going from point A towards point D, there is no external force, negative 5,000 is horizontal or uniform all throughout. And at point D, we have an upward reaction equal to 5,000 pounds. So we add negative 5,000 plus positive 5,000, that is equal to 0. So we go back to 0. In our shear diagram, we went from 0 back to 0. Next, we sketch our moment diagram. At point A, we don't have any couple. So we begin with a 0. Then we add the area of this rectangle, which has a base of 3 feet and a height of negative 5,000. So we have 0 plus 3 times negative 5,000. That is negative 15,000. So how do we connect 0 and negative 15,000? Since in shear we have a horizontal line, in moment diagram that becomes a linear graph. So we simply connect this two with a straight line. And at point B, we have a couple, external couple, which is clockwise, so that's positive 25,000. So we add negative 15,000 plus positive 25,000, that is equal to positive 10,000. So from negative 15,000, we go up to 10,000. After which we add the area of this rectangle, which has a base of 3 and a height of negative 5,000. So we add 10,000 plus 3 times negative 5,000. So that is equal to negative 5,000. So from positive 10,000, we go down to negative 5,000. Again, since this is a horizontal line in shear, this becomes a linear graph in moment. So we connect 10,000 and negative 5,000 with a straight line. And at point D, we have moment D, which is clockwise, so we have a positive 5,000 pound-feet. So we simply add negative 5,000 plus positive 5,000 pound-feet, which is equal to 0. So we go back to 0. In our moment diagram, we went from 0 and back to 0. From the moment diagram, the maximum bending moment is negative 15,000 pound-feet, which occurs just to the left of point B. So we can now compute for the maximum bending stress given by the formula, absolute value of M over S, where M is the bending moment, maximum bending moment, and S is the section modulus. Our M, the absolute value of our M, is 15,000, and to convert pound-feet into pound-inch, we multiply 12. And the section modulus of the section is given in the problem as 42 cubic inches. So calculating the maximum bending stress of the section is equal to 4,285.71 psi.